Part B of our first example. Suppose we want to find the cosine of 2 theta, and we're given this information here, okay? Now let's look at what we're given. We're given the cosecant is 25 over 24, and the cosine of theta is greater than 0. So if the cosecant is 25 over 24, isn't the sine 24 over 25? So the sine of theta is equal to 24 over 25. All right, now that's a positive here. What about the cosine of theta? Isn't the cosine of theta, if it's greater than 0, a positive? This time we're not given a quadrant which the terminal side of theta lies in, but we're given that the sine is positive and the cosine is positive. Where does that happen at? Which quadrant? Quadrant number 1. So I'm going to say that's angle theta, because that's the quadrant where the sine and the cosine are both positive. All right, let's construct our right triangle here. We'll call that a right angle. And then the sine is going to be 24 over 25. So this side is 24. The hypotenuse is 25, right? So I need to find my side A right here. Now, how can we find A? Using Pythagorean theorem. And just to use this to fast forward, we're going to say A is equal to the square root or plus or minus square root of C squared minus B squared. A is going to be a positive, right? So A will be positive square root of C squared, which is 25 squared, minus B squared, which is 24 squared. So let's see, if I put this in my calculator, it's a perfect square actually, and it comes out to 7. So I'm going to say A is equal to 7 here. So I have my triangle constructed. Now I'm going to find cosine of 2 theta like I asked for. All right, one of the formulas we had here was the cosine of theta squared minus the sine of theta squared. Now you could use one of the other formulas for cosine. It doesn't really matter. It gets the same thing. All right, but anyway, take the cosine of theta and square it. What is my cosine of theta? 7 over 25. Minus, take your sine of theta and square it. What's the sine of theta? Sine of theta is 24 over 25. And honestly, you could really plug that into your calculator, and then if it gives you a decimal, hit math, enter, enter, and it'll give you the fraction. So we get negative 527 over 625 is the simplified fraction. I don't think I really need to go over that part. All right, let's look at a formula in reverse. These double angle formulas, let's look at them in reverse now for the next example. Well, what do we have here? Our next example, it says find the exact value. In part A, we're going to have 2 times the tangent of 15 degrees over 1 minus the tangent of 15 degrees squared. Well, that looks a lot like that double angle formula for the tangent. What was the double angle formula for the tangent? It was something like tangent of 2 theta is equal to 2 times the tangent of theta over 1 minus tangent of theta squared, right? So notice what we have. We have exactly the same thing over here as what we have on the right side here, except for theta. What do I have in each spot there? Except for each one of these thetas, I have 15 degrees, right? So I have 15 degrees here, 15 degrees here. So what do I do then? I say that, okay, well this needs to be what? 15 degrees as well. Theta's 15 degrees. So what's 2 times 15 degrees? That'll be tangent of 30 degrees. So this thing will be equal to the tangent of 30 degrees. Well, let's figure out what the tangent of 30 degrees is. If I think about my unit circle, I think about 30 degrees. Where am I at on my unit circle? I'm at square root of 3 over 2, comma, 1/2, right? Cosine, sine. What is the tangent? It's a sine over the cosine, right? Sine is 1/2. So 1/2 over the cosine is what? Square root of 3 over 2. Well, that's 1/2 times the reciprocal, 2 over square root of 3. And what do we have? 1 over square root of 3. And we need to rationalize that, so we're going to multiply by the square root of 3 over square root of 3. So that's the square root of 3 over 3. Okay, that was part A. Part B. Part B, we're trying to find the exact value of cosine of pi over 8 squared minus the sine of pi over 8 squared. Well, that looks like my double angle formula for cosine. We had the cosine of 2 theta is equal to cosine of theta squared minus the sine of theta squared. Well, what do I have here? I have pi over 8 in place of this theta, and then in place of that theta, I have what? Pi over 8 as well. So what is theta in each one of these? Pi over 8. So for theta right here, let's put in pi over 8. Well, what does that give me? That gives me the cosine of what? 2 pi over 8, which is the cosine of what? Pi over 4, right? So I'm going to say that this is the cosine at pi over 4. Think about your unit circle. Pi over 4 radians. Which point are you at? You're at the point square root of 2 over 2, square root of 2 over 2, right? So what's my cosine of pi over 4? Square root of 2 over 2. It's just knowing those formulas, those double angle formulas. All right, let's look at a power reducing formulas. Power reducing formulas. Power reducing formulas. Power reducing formulas. All right, so your book says this. It says if we have the sine of theta squared, that's equal to 1 minus the cosine of 2 theta over 2. And then they give us one for the cosine of theta squared. They say that's 1 plus cosine of 2 theta over 2, like that, okay? All right, so let's see. We have tangent also, and we have the tangent of theta squared. That's equal to 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. Now, you usually see the sine and cosine a lot. The tangent, not as often. But anyway, let's suppose, now in the notes I have how to get the cosine squared of theta. Like I show you how to derive it. You don't have to know that. I was just showing you how to get that. I'm just going to skip down to the example where it says write the expression in terms of the first power of cosine. So we have cosine of theta to the 4th plus sine of theta squared. Now what do they want me to do? Write the expression in terms of the first power of cosine. So I want this just as cosines, but a first power of cosine. All right, sine squared. Couldn't I call that 1 minus cosine of 2 theta over 2? And then I would have like a first power of cosine here. So for the sine squared, I'm going to call that 1 minus cosine of 2 theta over 2. In other words, I'm using this identity right here. Now, I don't have an identity for the cosine to the 4th here. I have an identity for the cosine squared. So what I'm going to do is I'm going to call this the cosine squared of theta squared. So in the next step, I'll be able to use that identity. Let's use it now. What's the cosine squared? Cosine squared is 1 plus cosine of 2 theta over 2. So 1 plus cosine of 2 theta over 2 squared plus 1 minus cosine of 2 theta over 2. How do we square something? We multiply it by itself, right? So could I say this is 1 plus cosine of 2 theta over 2 multiplied by 1 plus cosine of 2 theta over 2? Sure could. Now let's just bring this stuff down. Plus 1 minus cosine of 2 theta over 2. Erase this. I'm going to need some room over here. Alright, so what happens if I multiply this stuff out? I get 1 plus, this is just what? Multiplying two binomials, so 1 times 1 is 1. 1 times the cosine of 2 theta is cosine of 2 theta. Now, cosine of 2 theta times 1 is cosine of 2 theta. And cosine of 2 theta times cosine of 2 theta is cosine of 2 theta squared, right? Now at the bottom, 2 times 2 will give me 4. Plus 1 minus cosine of 2 theta over 2. Now right here we can say 1 plus cosine of 2 theta plus cosine of 2 theta is 2 times cosine of 2 theta. Plus cosine squared of 2 theta all over 4 plus 1 minus cosine of 2 theta over 2. All right, they want this in terms of first power of cosine, right? So let's make a substitution here. So we're going to have 1 plus 2 cosine of 2 theta plus, instead of the cosine squared, what do I have? 1 plus cosine of 2 theta, right? Of 2 theta over 2. Now let's think about this for a second, okay? To rewrite this, I'm just going off to the side doing scratch work. Cosine squared of 2 theta. All right, what was my identity? My identity was what? Cosine squared of theta is equal to 1 plus cosine of 2 theta over 2, right? So what are they doing? They're taking what right here? They're taking theta and they're multiplying it by 2. They're taking this angle right here, multiplying it by 2, right? So for this part right here, what I'm going to do is I'm still going to write this 1 over 2 like this. Now, in here, I'm going to have cosine of 2 times whatever this angle is right here, whatever this angle is here. This angle is 2 theta, right? So wouldn't that give me 1 plus the cosine of 4 theta over 2? So if I use identity right here for this piece right here, that would be what? That would be 1 plus cosine of 2 times 2 theta, right? All over what? All over 4 plus 1 minus cosine of 2 theta over 2. All right, now let's see. Can I multiply the top and the bottom of this fraction right here by 2 to get rid of that 2 right there? I sure could. Let me do so. So I'm going to say 2 over 2 multiplied by this whole part here. 1 plus 2 cosine of 2 theta plus 1 plus cosine of 4 theta now we have over 2 all over 4 plus this stuff, 1 minus cosine of 2 theta over 2. So now, what do I get at the bottom here? I get an 8. 2 times 4 is 8. Now if I distribute 2 here, here, and here, what do I get? 2 plus 4 cosine of 2 theta. Then the 2 divides out with that 2, so I have plus 1 plus cosine of 4 theta, like that. Plus 1 minus cosine of 2 theta over 2 here, right? Now what I would like to do here, so I would like to go ahead and combine these two fractions, add them up. To do so, I need a common denominator here and here. So I'm going to go ahead and multiply this one by 4 over 4 to get my 8 at the bottom. So this part just comes down. 2 plus 4 cosine of 2 theta plus 1 plus cosine of 4 theta all over 8 plus, wouldn't this be 4 minus 4 cosine of 2 theta over 8? All right, so we have a common denominator, so I can write it down one time, 8. Now let's combine the numerators, okay? What will 2 plus 1 plus 4 be? 7? What is 4 cosine of 2 theta minus 4 cosine of 2 theta? Those are going to zero out, right? So what am I left with here? I'm left with plus cosine of 4 theta up top. Now I can break this up. I can say that's 7 over 8 plus cosine of 4 theta over 8. So I'm going to say 7 over 8 plus the cosine of 4 theta over 8. Now, it's in terms of a cosine to the first. No more signs in there, no more cosine squares, and so forth. All right, what I want to do is I want to end here, and then we'll pick up with the rest of 6.3 on Friday.